Welcome. This question says a resistor has a resistance of 6 ohms. What is the resistance of another cylindrical resistor? If its resistivity is doubled, its length is tripled, and its cross-sectional area is halved compared with the first resistor. So we have a new resistor. This is our R new. And we're going to compare it with our R old. And it has different characteristics. And we know what R old is. This equals 6 ohms. And we don't know what R new is. And so the first thing we need to do is figure out the relationship, and our resistance is equal to rho L over A, where rho is the material resistivity and L is the length of the cylinder and A is the cross-sectional area of the cylinder. And the layout we're going to use is R new over R old, the ratio of these two. Well, it equals R new over, and we know the value of R old was 6. And this equals, and now we look at these ratios. So it's the resistivity of the new material over the length of the new resistor over the cross-sectional area of the new resistor. That's what makes up Rn. And that's over the resistivity of the old material, the length of the old resistor, and the cross-sectional area of the old resistor. And then we're here and we're saying if its resistivity is doubled. I don't know what it used to be, but I know it's twice as much now, so the simplest thing to do is to call the old resistivity 1 and the new resistivity 2. And then I know that its length was tripled, so I don't know what the old length was, but I know the new one is 3 times bigger, so let's call the old one 1 and the new one 3. And then the cross-sectional area is halved. And so cross-sectional area of the old one, well, let's call it 1. And the cross-sectional area of the new one, well, let's call it 1/2. So now what I do is I work this out and I say 2 times 3, 6 divided by 1/2 is 12. So now when I look here, I say, well, R new over 6 is equal to 12. So that means that the new resistance is equal to 6 times 12. The new resistance is equal to 6 12s is 72. This will be 72 ohms is the value. So, you know, these questions, they reflect the fact that sometimes you don't know the absolute values of things, but you know how things were changed. So it's a useful skill to have. And it tests whether you know the equation that you're using to relate the different parameters that are spoken of. But then the next thing it does is it tests whether or not you can have a clear way through a set of ratios, and ratios can be quite confusing. Kind of like everybody knows you're going to maybe multiply by 3 or divide by 3, and maybe multiply by 2 and divide by 2, and maybe multiply by 1/2 or divide by 1/2. Everybody knows it's about ratios. The question is getting the ratios the right way round. And so this layout is the best way I've found for making sure I get the ratios the right way round. I always put the new version over the old version. I always find the simplest ratio to get me the answer. And then because I'm writing in complete sentences, because I have something equals something, I don't just have a whole bunch of math, but I have something equals something, I am not going to forget, which is probably the most common mistake that people make, I'm not going to forget to the Rn over 6 is equal to 12, and I'm not going to put down that Rn equals 12. When I get a problem with this, either people don't know the ratio, or the people don't know the equation, or I get a bunch of math that may or may not work out, or I get basically a correct math which gives me a value of 12, but then the student will forget that it's Rn over 6 which equals 12. And that, I think, most often is because they're not thinking in complete sentences. So don't be put off by these. If you know the equation and you know the layout procedure, it's points in the bank. So there we have it.